Hi everybody, in today's video we're going to wrap up our grapple hook feature. We're going to make it so that we can control the speed and distance at which it repels, make it hit things like walls, grapple to our door and our grapple point, and be able to cross this river. In addition, we'll even make it damage enemies. So if you want to figure out how to do that, then stay tuned. Hi, my name is Michael. Welcome to my 2D action and adventure RPG tutorial series. Follow along and learn how to create your own ARPG in Godot 4 using GD script. So in this part 2 of building our grapple hook, we're really going to get into the meat of it because, in the last video, we set up some of the things that we'll need to be able to grapple, right? Like we created this little impassable grapple obstacle stream here and these posts. And we even set up a few things in our player. Now we're going to be adding more to our player. And the way we're going to do this is we're going to create a new state in our state machine for the grapple hook. And that state is actually going to control pretty much all of the functionality. We're going to have to add a few things in here like a Raycast 2D and things like that. Now I just want to put a little forward too. As I worked on this, I actually kind of rebuilt this feature a couple times because I kept on running into issues. And I tell you this for a couple reasons. One, it's so that you understand, like if you're working on something and you keep hitting a wall and it's not working and there's bugs and you got to redo it, that's kind of normal and that's okay. And also, I just tell you this so that you understand that when I come up with a solution in here, it was the best I could come up with, and I certainly encountered issues. The primary issues I encountered, by the way, with this was that as I animated these collision areas and shapes, I was missing collisions when I expected them to happen on occasion. And so I wanted to iron that out because, if the player's ever playing a game and they're like, hey, the grapple hook should have hit, but it didn't. Even maybe if it didn't hit, but they felt like it should have, well, then the player's kind of right in that scenario. And so we got to build our features in a way that hopefully they work anytime they should be expected to reasonably by the player. So with that said, we're going to get into this. We're going to be adding a few nodes to this, but primarily we're going to be building this new state for the grapple and working it out. Okay, now the first thing I want to do before we actually add this state to our state machine, though, is just add a couple nodes that we didn't add last time. So in our last video, we did bring in a lot of the assets, and we even set up our grapple hook here, this 9-patch rectangles sprite in this grapple hook node 2D. We just need to add a couple things. I want a new audio stream player for the chain audio. We can use the existing audio stream players for other audio that we play back. And on top of that, I want to add the Raycast 2D. So let's add these real quick. So here in the grapple hook, I'm going to add just an audio stream player 2D, like so. And then I'm going to come up here to my interactions. And within the interactions, we're going to add this Raycast 2D node. So just come in here, add a Raycast 2D. And we haven't worked a whole lot with Raycast 2D nodes, but they just cast a ray in a line. Right? I'm going to go ahead and give this a name so that it's easily identifiable. And I'm going to call it the Grapple Raycast 2D. And I'm also going to make it accessible access as unique name here so that I can just reference it that way. That'll clean up our code, make it easier to find. And then if for some reason you move this, it'll be moved. Or you won't need to change your code to find that new location. Now, those are the primary changes that we need to make before we're ready to do this. We're going to control our Grapple Raycast primarily through our code. So I guess really the one thing that we need to configure on this is our collision mask. And we're actually going to be controlling stuff through code, but the layers that we want to check for collision on are going to be the wall layer as well as the grapple points. But actually, like I said, we're going to control this through code, so we can kind of just disable those and it'll work just fine. Now, under collides with bodies is fine. We're only using it against bodies. We could turn on areas if for some reason you decide to use grapple points assigned to an area 2D instead of a physics body 2D of some sort, like our static bodies, then you might want to turn on the areas. Now, other than that, I think we're good. So the reason why we put this Raycast 2D as a child of the interactions is because our player already rotates that interactions node. And so this is going to face with our player, which is going to make some of our code simpler. We don't have to worry about rotating that. And just to demonstrate this, I'm going to go here. Let's turn on visible collision shapes and then just run this scene. So we should see that the player's got this Raycast 2D node, right? And it's not colliding with anything right now. If I come back to the game and go over to my player and turn on layers 5 and 6 and save that. I think this will work. Then hopefully, there we go. You can see that it's colliding. It turns red when it's colliding with a wall. And that should also happen when it collides with this post, because layer 6 is the grapple point. Okay, so we're going to use that raycast to help us determine if we can grapple, or if its grapple hook's going to hit a wall, or if it's going to hit nothing, right? So there we go. All right, so let's go ahead now and set up this new state in our state machine. So I'm going to go ahead and just add a node. Any old node will do. And we'll call it Grapple. If you put 1P, it would be Grapple or something. Okay, now we need to make a state machine script for this as well. I'm going to go ahead and just pop open the idle script so I can find it here in the file system. And I'm going to just duplicate that. And we'll call it state_grapple. And once we've created this new grapple state, I want to come in here, make sure you're on the right one. And let's rename the class name like so. And I'm going to go ahead and actually delete a lot of this stuff. I just wanted this as a little template. There we go. Get rid of my handle input. Voila. Okay. This state is going to require some setup, obviously, and it's going to be a little bit more involved than some of our other states that we've created in our state machine, because it's going to handle the grapple hook movement as well as conditional movement of the player if it hits a grapple point and things like that. So it's going to be a little bit more involved than some, but it's not going to be terrible. And as we work through it, it should hopefully make sense. I'm going to go ahead and pop this script onto my grapple state like so. And before we set these up, I want to just kind of code it to make sure that we've got some basics working. So maybe in the enter, I'll just print a statement that says grapple state like that. And then we want to be able to hook and call the grappling hook state. So we've got our little state machine set up with this real simple state, right? But let's go to actually our, our player abilities script. And I've got that open. If you don't, then that can be found inside your player here. There should be a node for this, if I can find it. Let's see, there it is, abilities. So this is the script attached here. This is the script that we've used to do the work for our bomb and our arrows, etc. So we're just going to come in here and we're going to update this, because currently we're just printing a statement grapple hook when we have that ability selected. And of course, we want to change this. In here for our condition for the grapple hook, we'll call a new function that we're going to create, and we'll just call it grapple ability, like so. I'm going to copy this. We'll just come down here and make a new function for it. And this grapple ability, what it needs to do is basically a similar thing to what we've done in these others. In fact, this bow is a really good example. We don't need a check if we have a grapple hook count or anything like that. So we'll just come in here. I'm going to just copy this part of the if statement. And of course it says elif, so I'm going to change that to if, since it's the first part of an if statement. You can't do elif. Okay. And we're going to check the same things. We're basically going to say, is he in the idle or the walk state? Because otherwise we don't want to try and do the grapple hook state. Now you could change that. You could add or remove conditions to this statement. And we don't need to check the arrow count. All we need to do is change the state. And of course, we're not going to change it to the bow state. And we don't have the grapple hook state in here just yet. So let's go ahead and from our player, let's grab this new grapple hook state. And if you drag it while holding control and then drop it, you'll get that reference to it. So there we go. We've got grapple. That's the state we're going to return when we need to enter this. So just come down here to our function, paste that in. And now if we run the game, we should be able to get that statement printed, right, from our state here. It should say grapple state. So I'm just going to run scene 2. Make sure I switch over to the grapple hook and then press my ability button. And there we go. I said grapple state. And if well, I could try and use the state more, but we're stuck in that state. He's now in the grapple state and there are no exit conditions. So it's pretty broken, but there we go. Now we know we've hooked it up. Okay, let's dive back into this grapple state script. And what we're going to do next is we're going to bring in all of the different OnReady variables and things like that we need, and set up some export variables. So we need a reference to our idle state, because that's where we're going to exit normally. We also need a reference to a few of these nodes we've set up, like this grapple hook node. I'm going to drag that guy in there. And I want a reference to this 9-patch rectangle. We also want, let's see, we've got this little audio stream player we've added here, and I'm going to rename this to something like chain audio player. And I don't really want that little thing in there. Okay, chain audio player. That's going to be we're going to use this audio stream player to play like the chain sound effect for the grapple hook. And then we want some export variables. Essentially, we want to be able to control the distance that our grappling hook should extend when we use it. And we also want a speed for it to animate or to move. And then we'll export some variables for the different sound effects. Okay, so we'll start with our grapple distance, which this will be a float. And I'm going to set it equal to 100, I guess. The next variable will be the grapple speed, which will control how fast it moves. And I'm going to set this to 200. And then I'm going to export a group here and give this group a name of audio SFX, so that the next variables that I export will all be part of this group. So I'm going to export. We're going to have 3 audio effects that we're going to use. We're going to have one when we fire the grapple hook, one when it sticks to something, and one when it bounces, in addition to the chain audio, but we'll just drop that onto that audio player. We're not going to switch it. So grapple fire audio, which is of type audio stream. And I'll just go ahead and copy this line of code and paste it. And then let's see, we've got fire, stick, and bounce, I think is what we'll call them. Okay, let's go ahead and save that. I'm going to come up to my grapple hook state. You can see that we've got the variables here for our distance, our speed, and our audio effects. So let's go ahead and populate these sound effects real quick. So we did bring in to our player a bunch of sound effects. And so we've got them right here: grapple, chain, clang, fire, and stick. So fire goes to fire, stick goes to stick, and clang goes to bounce, because apparently I can't keep all my names consistent, but 2 out of 3 ain't so bad. Okay, so now we've got those sound effects hooked up, and while we're addressing the sound effects, let's go ahead and hop down to our grapple hook. This little audio stream player 2D here is where we're going to play this chain sound effect. Okay, so this is just a child of our node, right? So let's grab the grapple chain and drag it on, and I'll just preview this for you real quick. What we want with this sound effect is we want it to loop seamlessly or endlessly. So as long as the grapple hook is active, it'll just be playing. And so what we're actually going to do is, you can see that the loop mode is disabled, yada, yada, yada. We're going to come down here to grapple chain in our file system, and then we're going to go over to import, and we're going to adjust the settings on this import. And you can see that the loop mode is set to detect from wave file. Instead, we're just going to change this to forward. Okay, and loop begin at 0 and end -1. That's great. Just going to say reimport. And what that did, now we have a loop set up on this. The audio file will just loop as long as it's playing. And so all we need to do now to use this is just toggle this playing value of the audio stream player. So basically, whenever we enter the grapple hook state, we'll set playing to true, and then we'll turn it to false when we exit the state. Okay? So I think that's pretty straightforward. We've got the audio set up for this. We've got our different variables, our OnReady and export variables set up, and ready to move on to the rest of the script, I suppose. Okay, next we are going to add some just regular old variables to keep track of a few things within our state here. So I'm just going to come down here and add these variables. Now what we're going to do is we need to be able to keep track of a couple things. Like, for instance, we have a grapple distance, so this is the maximum length of our grapple hook, the chain, right? But we also need a value to keep track of the distance to anything that we're going to collide with, or that the grapple hook is expected to collide with. And so that's what we're going to do there. That's going to be determined by the Raycast. We also want to kind of help track what kind of object the grapple hook hits. Okay, so we'll have a variable for that. And then just a few things to keep track of, a couple other items. So these will make sense as we go through. But the first variable then will be that collision distance, which is a float. And then we'll have a variable for collision type. There's a couple ways we could do this. I'm just going to use a simple integer. And by default, I'm going to set it to 0. So there's going to be essentially 3 types of collisions. So we could have 0 if it's no collision, none. We'll have 1 if we hit a wall. And then we'll have a 2 if it's a grapple point. Okay, so that's just a simple variable that we'll store. It's going to help make the conditions easier to handle in here. And then we want a variable for, this is our 9 patch size. I don't know the best way to call this, but essentially this is when our grapple hook is at its smallest, what size is it? So let me just explain this by showing. Essentially what I'm looking at is, see the grapple hook's got, what I really mean, I guess, is the handle of the grappling hook. It's got a size. How many pixels is that? And this is going to help us know how to reset it and also how to do some basic math for extending the chain. Okay, so the size on mine, if you're using this, it's 25 pixels. Okay, and oops, I should say float. Okay, and it's a float because it could have decimal. And then we're going to be using a tween to animate the grapple hook. So I'm just going to create a tween variable here. So anytime we create a new tween, we'll assign it to this variable so that the state can keep track of it from different function calls. We also want a simple next state variable, which is going to be a state, and we're going to set it equal to null. And you'll see how we're going to use that. That's just going to be kind of our fallback so that we know when we need to change state, what do we change to? And then I'm going to set up 2 little arrays of variables, and I'm just going to plop them in here. So these are kind of odd, and I didn't want to bore you by typing them, but what we're doing here is we have 4 positions, and we have a position map. And essentially what we're going to do here is these are the positions that dictate where the grapple hook node should move based on the facing of the player, up, down, left, or right. And I'm using a vector 3. I just thought this would be an easy way to kind of hijack that, because I've got an X, a Y, and a Z. And I'm going to be using the Z for the rotation of the grapple hook node, and then the X and Y just for the X and Y positions. Okay, so that's what we're doing here. So when the player is facing up, we're going to move the grapple hook to 8 on the X axis, -20 on the Y, and rotate it by 180 degrees. If it's down, these are the positions, no rotation, and so on. Okay, and then this simple map is just a way for me to say, okay, we've got vector 2 up is 0 on our position. That's this one here. Down is 1, and so on. Okay, and these vector up, down, left, and right are the cardinal directions that our player is facing, because our grapple hook is only going to be able to shoot in a straight line. So I'm just going to use this value to help map the player's direction to a position for our grapple hook. And when we write that little bit of code, it'll make a little bit more sense, I hope. There might be other ways to do this, but this is just a way for me to kind of clean this up. The function that references these is going to have fewer lines of code as a result. All right. Okay, so those are all the extra variables that we're going to need in order to make this state work. So I guess we're ready to start building it. Okay, the next step with this state is we're going to do something that we haven't done for a while. We only use occasionally, and that's that we're going to be using an init, the init function for our state. So if you recall, we don't put this on every state that we have in our state machine, but in some cases, we want the state to be able to set itself up in a few ways, right? We've used it in the past so that the state can maybe listen to a signal from the player or something like that. But in this case, what we want it to do is we want this state to initialize this little grapple hook. So like by default, it's visible. We don't want it to be visible, right? That's one thing we're going to do in the init state is we'll disable that. So that'll be pretty straightforward. We'll just say grapple hook dot visible equals false, right? So that way, when we run the game, the grapple hook's not going to be visible. And then the next thing we're going to do is we're going to take our grapple raycast. Oh, did we not grab the grapple hook raycast node? Let me check. Dink, 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 dink. Oh, we missed it. Okay, so right after the chain audio here, let's get one more OnReady variable. Sorry, guys. And that's this. If we can find it in our interactions node, grapple raycast 2D. Oh man, that's an important one. Not going to work without this. Okay, So what we're going to do in our init is we're going to take this Raycast node and we're going to do a couple things. The first thing we're going to do is we're going to disable it. So enabled equals false. Actually, I'm going to comment that out, but we are going to do that. And I just want to show you why later. So we'll comment that out for now. But we're also going to take that same node and we're going to set the Raycast target position. So how this works, right, is the Raycast 2D has, I don't know why I'm selecting it, but it's not updating. There we go. The Raycast 2D has this target position, and you can come in here and move that target position if you click on it. Okay, and you can see that it adjusts that. We don't need to adjust the target position X and Y based on the angle because it's already rotating with this parent interaction node. Okay, so what we do want to do, however, is just set the Y value, because essentially this Y value is going to determine how long the Raycast casts. Okay, and because we have the ability to control the length of our grapple hook through the state via that export variable, we want to go ahead and set this target position based on that. So that was a really long explanation for just saying we're going to set the target position Y equal to the grapple distance. That way our Raycast is casting and checking the same distance that we're going to extend the grapple hook. Okay, pretty simple, pretty straightforward. But this way we're going to initialize our grapple hook and get it all set up. So now if I run my scene 2, we should see that the Raycast is longer and that grapple hook image is gone. It's no longer poking out when it shouldn't be. Now we want to set up our basic enter function. A couple things here. I did not set up an animation for our grapple hook. Okay. Now this is kind of me being lazy, but I just didn't have one and I didn't want to keep extending the player sprite beyond where it is currently. So what we can do is we can just say player dot update animation. And for now, what I'm going to do is set it to the idle animation. You could use a different one if you want, but that'll be fine for my purposes. But as you develop your animations, you may want to consider adding some special state or some special frames for the grapple hook. I'm also going to make the grapple hook visible at this point because we hit it in our init function, but we want to make it visible when we fire it. So we'll set that equal to true. And then we're going to have a series of pieces of functionality that we want to build. So I'm going to just make some comments. We need to set grapple hook position based on the direction our player is facing. We also are going to need to do our Raycast detection. So I'll say Raycast 2D detection. Yeah, cast. What the heck is that? Raycast. The Yacast 2000. That's like a really cheesy name for a karaoke machine or something. Okay, so Raycast 2D detection. We're going to then actually shoot the grapple hook. Okay, so after we've determined which way it faces and done a Raycast detection, then we'll initialize the hook shooting. One thing that I don't have to do a comment, we can take our chain audio player and we can call play. Lastly, we're going to want to play the fire audio. Okay, so if I save this right now and run, we should actually get a visible grapple hook and a sound effect. There we go. And now we're stuck. But it's working. And if you're wondering how I got that sound effect, I took the sound of a bicycle chain while a bike is being pedaled, and I bit crushed it. Pretty simple little method there. Okay, so we're going to have to go through and build the functionality for each of these, and then come back through and hook them up as we go. Okay, we'll come back to these. I want to flesh out just a little bit more here. We're going to pass on the exit function for now. We will come here and put some things in, but it'll make more sense to code that up once we've done the rest of the state. I do want to hit our process function real quick. We don't need to do much, but we just need to do two minor things. And first of all, we need to make it so that the player doesn't move. And let me just demonstrate why real quick. So if I'm moving and then I fire the grapple hook, then I'm just going to keep moving and I can't stop. I can't control the player. Okay. But what we want this to do is we want the player to stop walking. So I'm just going to set the velocity to 0 in the process function, and that's going to happen every frame, and that's fine. And then the next thing we want to do is instead of returning null, we're going to return next state. which is null, right? We've defined that here, line 24 in my code. So it's going to be returning null still. But what this allows us to do is once the grapple hook state needs to be finished, we just set next state equal to the idle state, right? Which we've kind of brought in here. And then the process function is going to automatically exit the state for us or call the next state. Okay. So that's what we're going to do with the process function. The physics function, going to leave blank, as will the handle input function stay blank. Okay. So we're not going to do anything with those because this is a pretty non-interactive state, which is ironic or counterintuitive, because once you hit the grapple hook, it's just kind of going to go and it's going to do its thing. It all depends on, you know, the timing and the position and direction of the player. What happens next? Okay. So with that said, let's jump back up to our enter function and we'll start going through and knocking out these other functions that we need to create. Okay. Let's go ahead and set the grapple hook position. I'm going to uncomment this and we'll just convert this to a function by saying set grapple, and I'm going to shorten it to set grapple position, like so. And of course that function doesn't exist, so it's going to not be happy until we create it. So we'll come down here to the bottom of our script and create that function right now. Okay. This function is going to be pretty straightforward. We're going to look at our player, see which way he's facing, and then set our grappling hook, you know, that little node with the sprite, to the proper direction. So we'll start by getting a new position. I'm just going to call it new POS, and this is a vector 3. And we need to store it separately because it's a vector 3, and obviously we're not using vector 3s anywhere else, right? We're in a 2D game, a 2D world space, so we're working with vector 2s. But we stored those as vector 3s, right? So what this is this is going to be equal to positions. We're going to find the position at the point where, if we look at our POS map, and that stands for position map, we want to look at our POS map and find the correlating value with our player's cardinal direction. Now that might seem a little confusing, but this player cardinal direction is going to be either vector 2 up, down, left, or right, right? So we'll pass that value into our position map, which is a dictionary. And if we look at that position map dictionary, right, we've got those vectors. So it's going to return the corresponding value, either 0, 1, 2, or 3. And then we can take that corresponding value and use that to look up the position. And this will become the index of that position, index 0, 1, 2, or 3, like so. Okay, so I hope that makes sense. There might be a better way to do this. You are free to comment below if you think there is a better way to do it, or if you have any thoughts on this. But we're going to go ahead and grab that. So that's our new position. Then we're going to just set our grapple hook position and rotation based off of these. So we're going to set the position equal to, we need a vector 2, so we'll create a new one. Okay, now this vector 2 is going to just consist of our new position's x coordinate and our new position y coordinate, just like that. Okay. And then we're going to use the z coordinate for the rotation. If you recall, we discussed this a little bit. So we'll say grapple hook dot. Now there's rotation and then there's rotation in degrees. Normally rotation is in radians, but we've typed those values in as degrees because that's easier for my brain. So we want to set the rotation underscore degrees equal to new position dot z. Okay, z is that third coordinate in a vector 3. Now we're basically done. However, there's one last thing we need to do. And if we look at our player, it'll be obvious. The grapple hook is displaying on top of the player. But if we are facing up, we need the grapple hook to be behind the player. And so we're simply going to do a check here. And we'll say if player.cardinal direction is equal to, which one is, oh yeah, we're looking at the cardinal direction. So if it's a vector 2 dot up, right? If the player is facing up, then we're going to take our grapple hook and then we're going to set the property show behind parent equals to true. Otherwise, that same value will be false. Just like that. Okay. So this is not a great test yet because we can only use the ability once. But now, if I'm, throwing a boomerang like I am apt to do, there we go. So now when we're facing up, it's behind the player. If we would have been facing any other direction, it would stay on top. Okay. So there we go. Set grapple position, function complete and implemented. Okay, let's go back to our enter function and let's look at what's next. And the next thing I have on here is our Raycast 2D detection. Now we need to talk about the Raycast 2D. Now in general, when I built this feature, I was having issues with collision detection. And so after several failed attempts with regular area 2D collision detection and still being buggy, I opted to move to the Raycast 2D, and believe it or not, I still had collision detection issues. And now they stemmed from slightly different reasons, but one thing that happens is we're going to be rotating this Raycast 2D, and there's always a possibility that the Raycast 2D may not actually detect collision for a frame or two after it's been moved or rotated, okay? And so this presents a unique challenge. If we go ahead and just run the game, because we're displaying our collision shapes, we can see the Raycast 2D. When it's blue, it's not detecting collision. When it's red, it is, okay? So generally, if it's red, we know our grapple hook is going to hit something, and if it's blue, it's not, right? And we also need to detect, is it hitting a grapple point or just a wall? Because we'll do two different things either way. But I have a solution for this that avoids some of the complication and some of the potential bugs, and it's actually a little bit over engineered to a small degree, but it's really useful and it's kind of cool. And so I want to continue to do it this way, partly just for the benefit of your knowledge of how to work with Raycast 2Ds, because you will likely run into situations like this in the future. But in a nutshell, what happens is if you change the position, rotation, size, etc. of a Raycast 2D, it might take a physics frame or even two before it registers collisions. Okay, that's just kind of how it works, right? Because it's going to change the rotation, position, etc. of that Raycast at the end of the frame. And so you've already lost a collision on that frame. And so you can't check that frame. And then depending on the rest of what's happening in your game world with collision shapes, it may not even detect on the frame after that. Sometimes it will. Occasionally, it's going to take two physics frames, okay? Which is super fast. Your player's probably not going to fill that, but this is just how it works. That's just what happens. And the same kind of thing happens with area 2Ds and other collision shapes. And this is why you can run into these kind of weird collision detection bugs that we tend to run into in Godot and even in Unity and other engines. Okay, so I've devised a simple / clever way to work around this. And we're going to implement that in our Raycast 2D detection function. So let's go ahead and create this. I'm going to call it Grapple Ray Detection, maybe. Yeah, we could just call it Raycast Detection. I don't care. So we're going to use a function to set the variables that we need on this. And obviously, we need to create that function. So we'll create it down here. We're not going to return anything. We're just going to run some logic and do some checks. Okay. And this is where we're going to go up here. I left the Raycast enabled so you can see it happening in game, but we're going to actually disable it. Okay. And I'll show you what this will do now when we run this scene with it disabled. That Raycast line is now gray. It's not going to turn red when it sees anything because it's not doing collision detection. And this actually has some benefits. We want to disable it when we don't need it, right? Because we don't need to be doing a Raycast every frame when we don't need the data. Instead, what we're going to do is we're going to enable the Raycast, and not only that, but we're going to use a special piece of functionality that Raycast 2D has in Godot, and that's called Force Raycast Update. So what we can do is, in fact, we don't even need to enable the Raycast. If we do a Force Raycast Update in this, in any process frame, Godot is going to say, hey, I need this Raycast to tell me what it's hitting, and I need it right now. You're not going to wait for the regular physics process. We're just going to make it happen. So you probably want to use this sparingly, I would guess, but we're going to use it, and we're going to use it twice so that we can detect collision of two different types from one Raycast in one frame without any delay, okay? So this will make sense now. Hopefully that if that explanation was kind of confusing, hopefully it'll make sense as we go through this exercise of building this function. Now, the first thing we need in here is we're going to set our collision type, because one of the things we're detecting is what type of collision. And the default is 0. So we're going to reset it to 0 here. And then we're going to also set our collision distance equal to the grapple distance. Okay, meaning if we don't have anything that we collide with, then this distance should be the maximum length of the grapple hook. Okay, so we'll just set those two values because we're going to use them later on in our code. And then what we'll do is we're going to grab our grapple hook, or not our grapple hook, but our Raycast 2D, and we're going to enable the appropriate collision masks for us to check if we're colliding with a grapple point, okay? Because if you recall, we've got walls that we can collide with, and we've got grapple points. And if we look at up here, we're saying grapple points, we're going to assign the value of 2, and a wall, we're going to assign the value of 1. But essentially what we're going to do is we're going to do a Raycast detection first on the grapple points. So this way, if you've got competing things like there's a grapple point on a wall, which we actually do have in here with our door, those grapple points and the walls, the collision shapes kind of match up. Okay, we want to check the grapple point first and honor that over the wall. And so in order to do this, we're going to set a collision mask value. And what we want is we want to disable walls. So that is that layer is layer 5, and we're going to set that to false. So you're no longer detecting walls. And then we're going to take the layer for our grapple points, which is 6, and set that to true. Okay, so we're saying, okay, just check this layer. And if we were checking this one previously, set it to false. And then we're going to call this force raycast update that I mentioned. Grapple raycast 2D dot force raycast update. Okay, so this one line of code, this little function, if we look at it, updates the collision information for the ray immediately without waiting for the next physics process call. Use this method, for example, when the ray or its parent has changed state, which for us, it will, because we're basically telling it to be enabled. This is really interesting. See this note right here? This is the most curious part of this that I learned while building this. Enabled does not need to be true for this to work. So we've disabled our raycast. It's not detecting collisions, but by calling this force raycast update, it will. Okay, and we don't have to enable it and then disable it. So it's kind of nice because it gives you that immediate feedback. So we're going to avoid some of the potential bugginess of waiting for physics frames, and we don't have to worry about enabling and disabling the raycast. Okay, so there we go. Kind of cool, right? And then what we'll do is we'll just handle if we have a raycast here, because essentially this, when we turn this on, the ray is going to do one of two things. Either it's going to collide with a grapple point or it's not. Okay, pretty straightforward. So we're going to say if grapple raycast 2D dot is colliding. If that is true, that means we've hit something, and we're going to return because we're not going to do anything else, but we'll just do a little bit of code within this. And what that code is we're going to set our collision distance and our collision type. We know that the collision type is 2 by virtue of the fact that we're detecting against this layer 6, which is our grapple point. Okay, so we'll set that value to 2, and we will also set our collision distance equal. So our collision distance is going to be something that we have to calculate, and what we can do is grab our grapple, grapple raycast 2D. We can get the collision point. This is a function that we have, and if we look at this, returns the collision point at which the ray intersects with the closest object. And this is only going to be objects on this layer, right? So it's just going to give us the spot, like the coordinates where it collides. And then we're going to get a distance 2, not distance squared 2, distance 2. And then we just want to get our player's global position. Okay, that's going to give us a distance. So that's going to say from this little point at his feet, which is where our raycast originates, how far until we hit another object. Okay, so there we go. Pretty simple. And then we return. We've done our job. Now, if we don't detect a collision here, then we're just going to kind of copy this code. And now we're going to check different layers. So we'll set layer 5 to true. Now we're going to check walls. Okay, we didn't hit a grapple point. What about a wall? Are we going to hit a wall? So we need to set 6 to false. And then we'll force again. So we're going to get 2 raycasts in one frame, which is kind of cool. This is where you got to be careful though, because if you had this in a loop and you did like thousands, you're going to tank your performance. So now if it's colliding, we know that the collision is of type 1, right? And we can use this exact same code to get a collision distance, and then we're done. Okay. Otherwise, if neither of those happen, then it's going to default to no collision, and the distance is going to be the maximum distance. Okay. So there we go. There's our Raycast detection function that we're going to call here in our enter function. Now, real quick, let's go ahead and just test this. And what we'll do is we'll just print whatever we hit. Okay. So what we're going to do is we'll print, what is that? The collision type, maybe. And we could also print the collision distance. Now, so that we can test this, I'm going to also set our next state equal to idle. And then let's go to our exit state and we'll set next state back to null. This will allow us to test this a little bit. Okay, so let me just grab my scene here and run this. Okay, hopefully I can shoot this. Well, it's not exiting kind of completely, but what we can do here is now if I look at this wall, the arrow's not red, but we can see from the distance it should collide. So if I check that, you can see that I did have a collision type of 1 at a distance of 86.2 pixels. And if I pointed at this door, it was collision type 2, right? Meaning that we collided with one of our grapple points, and that was the distance. If I point it down, you see collision type 0 happening there. And then lastly, at this post, type 2. Okay. So our Raycast is working. The rest of our state sucks, but the Raycast is working. I'm going to go ahead and just remove these and that because we don't need it. And then we're ready to move on to the next step. Now that we've got that working, I'm going to skip down to this play the fire audio because this is something easy and we're going to want this audio playing functionality for other parts of the script. So let's go ahead and assume we're going to have a new play audio function, and the fire audio, we can just pass that in. Let's see, grapple fire audio like that. Okay. We need to obviously create said function. So we'll go down to the bottom of our script and make it. Now this play audio, of course, is going to require us to pass in just a simple audio stream that we can play back, which is what that grapple fire audio is. This will be audio of type audio stream. And then this is pretty simple. We're just going to grab our player and grab his audio stream player, which those words are kind of synonymous, so that's confusing, but player.audio.stream. We need to set that to this audio file that we grabbed because we have a reference to that within our player, right? Within that class that we built. And then we'll just say player.audio.play. Okay, so now we should get an extra sound effect when we fire our grapple hook. Let's go ahead and test that real quick. It works. It works. Okay, there we go. Now we can call this in other places when we want to play some audio. All right, I'm back in the enter function and things are coming along swimmingly. So we're going to move on to the last function that we need to create here, which is shooting the grapple hook. Let me go ahead and just create this here. I don't know what we should really call it, but shoot grapple is what I had called it previously, so we'll stick with it. Okay. I typed that in a weird order. But what does this function need to do? This function is going to be responsible for a lot. In fact, it's going to call some other functions, but this is going to initiate the sequence that this state is going to go through, right? It's going to shoot the grapple hook. The grapple hook needs to collide or hit the end of its rope and then retract. And if it collided with a grapple point, it shouldn't retract. Instead, the player should suck to it. The player should retract. I don't know what we call that, but the player should move, not the grapple hook itself, right? But it'll still retract. I don't know. Confusing, but not. You know how grapple hook works, I hope. So let's get started with this. So the first thing we're going to do or work on in our grapple hook script here is that we're going to be using a tween to animate that 9-patch rectangle, which is the grapple hook, right? And the reason why we've stored this tween separate is so that we can use one tween for all the tween animations, and then we can interrupt it if we need to. So like if the grapple hook hits a wall, we need to stop the tween early, for example, okay? So in order to do that, we're going to just check. Anytime we run a function where we're going to manipulate the tween, we're going to check if we already have a tween. If it's null, this is going to pass this. Otherwise, we're going to call this tween.kill. function. Okay, and let's just look at that real quick and review it. Aborts all tweening operations and invalidates the tween. Okay, so basically get rid of the tween. And then what we're going to do is we need to set up the tween. Since this is shooting the grapple hook, we shouldn't probably need to kill the tween, but just in an off chance, right? What we're going to do is we're going to check, we're going to create a tween that incorporates the distance to our wherever the grapple hook is going to collide, the speed of the grapple hook, and go from there. So we'll say, let's make a new variable for our tween duration. Let's start there. So we have, this will be a float. We have a distance because we've detected our collision distance in our Raycast, right? Before we called this, so if we look at the enter, Raycast detection is going to get us that distance. And we can divide this by the grapple speed. That's going to give us the duration. Okay. Now we're going to set our tween to, we're going to create a new tween, I guess I should say. So we're going to create a tween and we're going to assign it to this tween. So now we can just access it through that, right? Which makes this line of code work, possibly, conditionally. And then we're going to tween. We're going to tween.tween property, which allows us to take a node, pick a property, and tween it, right? So the node that we want to tween is going to be our 9-patch rectangle. And the property we want to tween is the size. And then on the next line, next we need to tell it what we're tweening the size to, right? What that final value is. And this is a vector 2 because it's an X and a Y. So we're going to say vector 2. And first we're going to take the size on the X, the width of that. We don't want to change that. So we're just going to keep that as is. And then for the Y, we're going to set it to the collision distance. Okay. Lastly, what we need to do with our tween is just give it a duration, which we calculated. That's our tween duration. There we go. Okay. So that's the tween. That's going to allow it to play. And we need to do a tiny bit of conditional code here based on the type of collision. But let's go ahead and just test this and see what it looks like. See if it works at all. We should see an animation. Oh no. It failed. Invalid access to property key X on the 9-patch rectangle. Okay, let's go ahead and stop our game. Oh, I see why. Because we're not getting the X at coordinate of that. We need to get the size.x. So my mistake, I missed that. Okay, because obviously this is what we're manipulating. That's also what we're getting that X coordinate from. Let's try that again. It should work this time, I hope. Okay, it went out. Nice. We can see the distance and it worked over an amount of time. That looks a little goofy. Maybe we need to adjust our positioning. But it's working. Now, as we saw that the grapple hook just went out and it stayed there because we don't have a way to handle what happens after the tween is completed. And so what we're going to do, we're going to handle that with this condition because there's two things we could do, right? We can either return the grapple hook to the player or have the player go to the grapple hook. So we'll determine that based off of our collision type. So we'll say if, not collision distance, but if collision type equals 2, then we know that we need to have the player grapple. Okay, so what we're gonna do is we're gonna set a tween callback. What a tween callback is and does is it says once this tween is complete, call a function. So we're gonna say tween.tween callback. And then in here, we need to provide the callback function. Okay. And so we're going to make a new one. We're going to call grapple player. Copy. So we'll just put that down here. This is a new function. There we go. And then likewise, or otherwise, I should say, else, if it's not of type 2, if it's either 0 or 1, either if it hits a wall or it gets to the maximum distance, right? Those are the two conditions there. Those are both going to return the grapple to the player. So we'll just kind of copy this. And instead of grapple player, we'll say return grapple. Okay. Create that function. And there we go. Those are the two functions that we're now going to have to work in. And these are going to allow us to handle those, right? So when we look at these functions that we just created, grappling the player versus returning the grapple to the player, let's start with this one. It's simpler, it's easier to test. It'll let us get this feature more full cycle earlier. So return grapple. What is it going to do? It's just going to kind of do the opposite, right? So we're going to just, in fact, we can take a lot of this stuff right up here. I'm just going to copy those lines of code from the shoot grapple, and I'm going to paste it. Oops. There we go. So we want to kill the tween. We still need to calculate a tween duration, just like this. Collision distance, grapple speed. It will be the same as previously, but this is a local variable that we're calculating, so we need to calculate it here. We'll create a new tween. We'll tween this property. Now this one we're going to tween differently. Instead of going to the collision distance, we're going to tween this to the 9 patch size, okay? Which is kind of a misnomer. It's just the y coordinate, but you know, that value that we set before, which I've determined for us is 25. Okay. And then we do need a tween callback on the return grapple as well. We just don't need it to be conditional because there's only one way to handle this. So we'll say tween.tween callback, and this will be grapple finished. Let's go ahead and copy this, make this last function, I think. And what the grapple finished is going to do is pretty straightforward. We're going to just set our next state, just like that. So then what this should do is if we have a regular kind of situation here, we can shoot the grapple and it should come back to us. We're going to have to extend this a tiny bit, but let's test that much. There we go. It put us back to the idle state. Our exit isn't set up. This is a good time to go and do that now. So let's come up to our exit. A couple things that we need to do. Make our grapple hook not visible. So we'll say, let's see, grapple hook visible equals false. We're going to stop our chain audio from playing. Stop. We'll kill any tween that we have. Maybe not necessary, but just to be careful. And then lastly, this shouldn't really be super necessary, but we're going to take our 9 patch rectangle, set the size.y equal to that 9 patch size. There we go. So now it should exit a little bit more cleanly. Let's go ahead and test this again. There we go. Now, if it hits a wall, it should be shorter. You see that? The only thing we're missing is the little sound effect. So let's add the sound effect. And to do that, we're going to go down to our, let's see, what was that function called? Return grapple. We'll just do a quick check in here. We only want to play a sound effect if it hit a wall. So we'll just say if, let's get our collision type. And if it's greater than 0, if it's 0, it didn't hit anything. Otherwise, it hits something. We'll just play audio, and then we're going to play the grapple bounce audio. Let's test it one more time. There we go. Okay, so now our grapple hook has kind of its, I don't know, normal and fail condition. It just doesn't yet work here on grappling to the post. All right. Okay, this grapple hook is working pretty dang good. So let's go on to, I guess, the last big bit that we need to work on. And this is when the player hits that grapple post, right, or a grapple point. What are we going to do here? This one's going to be a little bit different. And I hope that this methodology that I'm laying out here makes a little bit of sense. But essentially, right, but what we're going to do is I mean, it's going to be really similar, but instead of simply animating the grapple hook, we also need to animate and move the player. And so we can reuse some of this stuff. I'm going to go ahead and just copy this for now. Same stuff. Because again, if we've got a tween, let's go ahead and kill it and we'll make a new one. If we're grappling the player, we know that we hit a grapple point. So we're going to play audio for that. And that's the grapple stick audio. Oh, there it is. Now, one more thing that we're going to do here is we're also going to disable the collision mask for our player that's looking for this grapple obstacle. So if you recall, that's layer 4, right? And so we're going to go player, because he's a rigid body 2D, we will set collision, let's see, collision mask value, meaning we're no longer going to have the player look at a certain layer for collision, and that layer will be 4, and we will set it to false. We're also going to have to set this back to true. And the place that we'll do this real quick is just in our grapple finished function here. Okay, we'll just add this line. I mean, even though this gets called in other circumstances, it's fine. If it's already true, it's not going to break anything. Okay, so we'll just set that. Okay, let's go back to grapple the player, right? Okay, so we're disabling that collision so that we don't have any issues there. We've got our tween duration. That looks fine. We can keep that. We can create a tween. We are still going to do, actually, we want to copy, we should have copied this one, I guess, but I want this version of the tween for the grapple hook because it still needs to go back, right? The grapple hook still needs to move back to the handle. But in addition to that, we had to move the player. And so this is where it gets a little bit more involved, but it's nothing too crazy. We're going to calculate a target for the player to be at. So this is going to be called, we'll call this player target. And by target, I mean like which location should he move to? So this is a vector2 position, and this will equal the, let's see, we're going to grab the player's global position to start. And then we want to add on that collision distance. So we're going to look at the player's position, and then we're going to say, okay, we have a distance. We know we collided. Let's say it was 80 pixels. So we need to move 80 pixels, but we also need to know in which direction. And we can calculate that by using our player's cardinal direction, because the player's cardinal direction being up, down, left, or right is like, you know, a vector2 of 0 and 1, or 1 and 0, or -1 and 0. So if we multiply that vector2 by the distance, then it's simply going to say, like, if it was -1, if our cardinal direction was left, then the vector is going to look like -1, 0. And then if we multiply that by the collision distance, then this is going to, whatever that distance was, let's say it was 60, this becomes -60, right? If it was 1 here, then that becomes 60. You see my point though, right? We're basically going to take that cardinal direction and use it to get a vector2 with a magnitude that equals the distance that we should have grappled. So we're going to say player.cardinal direction multiplied by the collision distance, and go ahead and just close that. What did I do wrong here? Oh, and we're adding this to our global position. There we go. Okay. So that's how we're going to calculate our player target. And then we also need to adjust it just a little bit, because we don't want our player to be like inside the post when he gets there. So we're just going to adjust it. We're going to say player target. And actually, you know, we could do this. We could take this line of code. Let's do this. This is nice. This will make it nicer, easier to read. Okay, so we're going to start by setting our player target to the global position, and then we're going to say player target plus equals, we'll add that on, and then we're going to do one more adjustment to the player target minus equals, and then here we're going to grab our cardinal position again, so player.cardinal, or cardinal direction, I mean, and we're just going to multiply that by 10, so it's just going to move him, here we're moving him whatever that distance is in a direction, and then we're going to back him up 10 pixels in the opposite direction. Okay. Now we're ready to make a tween. So we're going to make a new tween, and we want this to be parallel. Okay. So what tween.parallel does is it means this tween do with the previous one we defined. So we're going to make, now we can say new tween property. And then in here, we're going to tween our player this time, and we're going to tween his global position. And we're going to tween it to the player target, which we just calculated, and we'll do it over the tween duration. Same duration as the grapple hook. So there we go. We've got now 2 tweens happening simultaneously. I'm also going to make the player invulnerable. So we'll say make invulnerable. The duration of that will also be the tween duration. So while he's grappling, he'll become invulnerable. And then lastly, we just have the tween callback. Because we have these two tweens and they're both in parallel, then what happens is this callback is going to wait for them both to finish. They both have the same duration. They'll finish at the same time. But yeah, in fact, I don't even need to type that. Let me just come down here, copy that callback line, clunk. There we go. So now if we run this scene, and if everything works, then our player should be able to grapple onto something. And I can't get across the river. We're going to have to adjust the length of the grapple hook, but that worked, right? And it played a little different sound effect. Like a sound effect, okay? And it's working. This grapple hook is slow and not very long. It needs some adjusting. We exported variables for that, so we can kind of fine tune it and tweak it. And one other thing I want to do is I want to make it so that our grapple hook can maybe hit enemies. That'll be kind of fun, so we'll add that as well. But up until now, we've built basically a fully functioning grapple hook. We just have some refinement to do to it, which is what we will do next. First thing I want to do is I want to adjust this grapple hook. It was kind of short, kind of goofy. It was really slow moving, and it couldn't get across that little stream. So I'm going to go ahead, before we test it again, though, I'm going to turn off these visible collision shapes. I don't think we need that anymore. But what we can do to adjust that is just come to our grapple. Let's increase the distance. I'll make it maybe 150, increase it by 50%. And I want to increase the speed as well. I'm going to put 400, and let's just give that a whirl and see what it looks and feels like. Ooh, a lot farther, a lot faster. Nice. That feels a little bit better. I missed the post barely. There we go. And now I can get across this river. So we weren't able to cross this river, but now we can. Pretty cool. Pretty cool. Pretty cool. Okay, so that's working better. We still can't attack the enemies, but we'll take care of that next. Ouch. And I can take damage unless I grapple onto something, which I think is fine. If you don't like that, you can change how you make him invulnerable, or, you know, add some other effect to it maybe. Okay, let's look at making this grapple hook deal damage. So we are going to have to come back to our player and add to this, because I don't really want to use this Raycast for damaging the enemies. We are going to use you know, our hurt and hitboxes to do this. So there might be a tiny bit of bugginess in this one, but I don't think it's going to matter, because the player's collision shapes are large enough that we shouldn't run into any collision issues that I was running into in my previous test. So here's what we're going to do. We're going to go to our 9-patch rectangle, and we're going to actually add a node within this. Now, if you remember how this works, right, this thing scales and moves tiles automatically, and it's this weird control node. Okay, so I'm going to go ahead and just make it bigger for a second, just for testing purposes. Now, underneath the 9-patch rect, I'm going to add a control node. Boink. And then as a child of this, I'm going to add a hurtbox. So let's go Shift Control A, hurtbox. Now, of course, this needs a collision shape for it to work properly. And of course, collision shape needs a rectangle shape. I kind of wish it would just automatically add one of those. I don't know. Let's make it red and, yeah, make it somewhat transparent there. Okay. Now, this is kind of interesting. We've got our hurt box. You can see the control here is this box. And right now our hurt box is in the top left. Okay. Which is fine. That's fine. Everything's fine. It's fine. It's fine. We need to make it smaller. So I'm going to just go to my collision shape and maybe, I don't know, drag it in a little bit. It's okay to be kind of taller. Now this is going to rotate with the grapple hook as we move that around. Now this control, see, this hurt box is centered right in the control. Because you see where the control is? Or no, it's not. It will be. It will be. Because I'm going to make the layout small. 0, 0. Okay, now it's centered on it. Okay. Okay, so there's my control. It's now just this little point. And what we're going to do is I'm going to come down here to the anchor presets for this control. Because the control is inside of another control type node, we can use these anchor positioning settings. So I'm going to use this center bottom. Boom. And you see what it did, right? It moved that down there. And what's cool is as I resize this 9-patch rectangle, that is moving with it. I just want to adjust my hurtbox a tiny bit. Now that that's there, I'm going to drag it up more like this. Okay, so there we go. So as our 9-patch rectangle animates, then this hurtbox should begin functioning. Let's go ahead and test that. It's going to be a little bit flawed because this hurtbox is always on currently. But let's see. And actually, before we test that, so let's just see. So let's turn on our collision shapes again so that we can see it. We should be able to see that that hurtbox is animating. And there we go. You see that red box at the tip? Let's go see if it hits an enemy. And it should. Oh, I missed. Oh my gosh. Well, it's not working. You know what the problem is, though, I think, is let's look at our hurtbox and let's look at the collision configuration. By default, our hurtboxes are on the player hurt layer. We want to make them hurt enemies like that. So make sure you change that mask setting to enemy. Let's test again. The dogs are barking. Somebody's home. Okay, boom, nice. Grapple hook destroyed that little goblin. Come back here. And there we go. Okay. So now that our grapple hook does damage, we just need to add a little bit of extra code to our state so that we can disable it when we're not using it. Because man, those dogs are going nuts. Because otherwise, I don't know. Oops. No, I don't know. Maybe it's not. Maybe it's not out there being active, but I just want to be careful. So let's fix that. Okay, now that I proved that maybe this is not completely necessary, let's go ahead and do it anyway. So I'm going to go into my script, the grapple state. Now, essentially what we need to do is just enable and disable the hurtbox, right? So first item of business is to get a reference to it. So we can come in here to our player. And in fact, let's go ahead and give this hurtbox a name. We'll call it Grapple Hurtbox. And this way we can access it by that name. Makes our code a little bit cleaner in here. Okay, Grapple Hurtbox. There we go. So we're going to be enabling and disabling that. The first place we need to set it is, let's just go down to our init function, and I want to disable it here. So grapple hurtbox dot monitoring equals false. And we'll just copy this line of code. Okay, so by default, we disable it. Then let's see, in our enter function, we can, let's just do it here with grapple hook visible. We'll set this to true in here, like so. Our exit function, we can find it right here. Set it back to false when we exit. I guess that's it. So here we go. Just save it and just make sure it still works. Oh, I kind of hate the collision shapes when I have so many turned on. But let's make sure I can still kill Goblin with this thing. Voila. So there we have it. We've built a functioning grappling hook. It allows us to configure how fast it moves, the distance at which it can be shot. We can grapple across these obstacles, and we can even destroy goblins in their faces by shooting them with the grapple hook. Bounces off walls. Quite a lot of functionality in this simple little grapple state. So I hope you guys are appreciating this content. You know, I'm getting to the tail end of this action RPG series. I'm going to be teasing pretty soon some of the things that are coming up next. But for those of you who've been following this series for so long, thank you so much. And I hope that you're still getting stuff out of it. There's still a little bit of work left to do on it, of course. We're going to do a little bit more by making these abilities obtainable, unlockable, and save that into our player state. So, you know, that'll be coming up as well. But for those of you who are sad, go ahead and tell me why you're sad in the comments, and talk about maybe what it is that you want to see next. I know there's features we didn't add to this. One of those that I think is pretty big is a map system. And I promise I will be building a map system. It'll be part of the next project, and it'll be compatible with this in a lot of ways. And so, you can always grab that, bring it back over here. And if the outcry is large enough, maybe I'll do the map system specifically for this game as well. Only time will tell what I'm going to do with that. But with all that said, I just want to say thank you again to everybody, especially my Patreon supporters. If you're new to the channel, please subscribe. It helps me grow, and drop a comment, blah blah blah, all the things that people ask for you to do. And as always, we'll see you next time.